All right. Hello, everyone. On behalf of the Environmental Finance Center Network, welcome to our webinar on wastewater system operation and maintenance. My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits. Eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have any questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, we can go ahead and get started. I would like to introduce our presenter for today, KT Newman. KT is the owner of Utility Contractors, LLC. Welcome, KT, and I will hand it over to you.
Thank you. Thank you so much. Hello, everyone that's attending this webinar. As stated, my name is KT Newman, and I am the owner of Utility Contractors. At Utility Contractors, we provide operations, maintenance, and training to water and wastewater clients across the state of Mississippi. I'm thankful for the opportunity to be here with you today to discuss wastewater system operation and maintenance as it relates to collection systems. Our target audience today includes operators, policymakers, and others who may have an interest in the operation and management of wastewater collection systems. While this discussion centers around the duties and responsibilities normally associated with the operator, there's unquestioned benefit for mayors, council members, engineers, and virtually anyone who plays a role in the day-to-day task of wastewater treatment. In fact, from the administrators in the office to the crew members performing excavations and inspections, and all points in between, there are essential roles played by all in a shared responsibility to help ensure the safety and well-being of our communities as it relates to wastewater treatment. A wastewater system is usually one of a community's largest infrastructure investments. Identifying and fixing problem areas in your sewage collection system maximizes the useful life and performance of this asset, and also protects the public health and welfare of your community. Communities across the United States are working to find cost-effective, long-term approaches to managing their aging wastewater infrastructure and preventing the problems that lead to sanitary sewer overflows. Many communities across the country are struggling with the ability to maintain their wastewater infrastructure. Renewing the country's aging water and wastewater infrastructure is a key concern of water and wastewater utilities across the country. EPA reports on wastewater estimates that the nation's wastewater treatment facilities will need $271 billion over the next 20 years to meet federal water quality objectives. Ongoing evaluation and planning are key components of America's water approach to combating infrastructure needs. The specifics approach are varied, but all involve focused planning for the future to avoid service interruptions or public health emergencies. Sanitary sewer overflows, or SSOs. Sanitary sewer overflows are a release of untreated or partially treated sewage from a municipal sanitary sewer. SSOs occasionally occur in almost every sewer system, even though systems are intended to collect and contain all the sewage that flows into them. When SSOs happen frequently, it means something is wrong within the system. Because SSOs contain raw sewage, they carry bacteria, viruses, protozoa, parasitic organisms that cause disease. As a result, they may cause diseases ranging in severity from mild gastroenteritis, causing stomach cramps and diarrhea, to life-threatening ailments such as cholera and dysentery. Some of the causes of sewer system overflows, perhaps one of the biggest reasons is inappropriate materials sent to the sewers. Materials such as fats, oils, and grease, and some household products, including some marked as flushable. Tree roots entering through defects or openings in a sewer line may also cause blockages. Leaking sewers, stormwater, groundwater, and snow melt entering the sanitary sewer from cracks and faults in the sewer or leaky sewer joints can overload a sanitary sewer. Inappropriate connections. Connections of water such as sump pumps, roof leaders, foundation drains, and area drains can overload a sanitary sewer as well. Improper or inadequate maintenance and cleaning of sewers. Inadequate pump maintenance and lack of backup power. Undersized sewers and or pumps and equipment failures can all lead to sewer system overflows. During today's presentation, we're going to provide training on the safe and effective operation and maintenance of wastewater collection systems. Although the wastewater profession is not normally categorized as a health profession, few could argue the impact of the decisions we make daily on the health and well-being of our communities. It thus becomes paramount that our collective efforts result in safe and effective operations. We're going to also discuss issues to train operators in the practical aspects of wastewater collection system operation and maintenance, as well as focus on the knowledge and skills operators need to identify system problems and select appropriate methods to solve them. Maintaining wastewater collection infrastructure, which consists of pump stations, forced mains, and sewers, is an integral component of the proper management of a treatment system and critical to preventing illegal wastewater releases. Effective operation and maintenance programs have been shown to significantly reduce the frequency and volume of untreated sewage discharges, help communities plan for the future, and save money on emergency response. The quality of the operation and maintenance of a wastewater collection system depends on effective operation and maintenance of numerous elements involved in such a program. This will assure an operation and maintenance program that will keep a wastewater collection system functioning at its top efficiency, maximize its useful life, and minimize costs. The benefits of a proper wastewater operation and management plan: communicate with and educate citizens and local officials, address financial and regulatory needs, develop and conduct preventive maintenance programs, better manage infrastructure assets, improve system capacity, and address sewer system overflows. Historically, municipalities have used two major types of sewer systems: combined systems, combined sewers, and separate sanitary sewers. Combined sewers are designed to collect both sanitary sewage and stormwater runoff in a single pipe system. State and local authorities generally have not allowed the construction of a new combined sewer system since the first half of the 20th century. Separate sanitary sewers, the other major type of domestic sewer design, is also known as a separate sanitary sewer, are installed to collect wastewater only and do not provide widespread drainage for the large amounts of runoff from rain events. Sanitary sewers are typically built with some allowance for higher flows that occur when excess water enters the collection system during storm events. What is a wastewater collection system? A wastewater collection system is a series of pipes and devices that includes main lines, manholes, lift stations, and private laterals that transport wastewater from homes, businesses, and industries to a central treatment facility. Collection system O&M is an essential element of wastewater treatment. Effective inspection, cleaning, and rehabilitation are key processes for optimizing the proper functioning of a collection system. Just like your car, it will eventually fail to perform without regular maintenance and repairs. So what O&M tasks should we be doing? Studies have shown that optimizing collection system performance depends on specific maintenance tasks and frequencies. You should summarize and review your maintenance activities each year. These practices are the foundation for not only building, but also sustaining the technical, managerial, and financial capacity of wastewater. Do you know the condition of your sewers? Condition assessment of your collection system is an investment in managing risk. Knowing the structural condition of your underground assets will allow you to avoid emergencies, prioritize repair and replacement projects, and plan for the future. Maintenance issues are the leading cause of backups and overflows of collection systems. Condition assessment helps utilities discover maintenance and capacity issues before they become maintenance problems. Knowing how your collection system really works will identify trouble spots and lead to preventive maintenance decisions rather than being reactive to the consequences of emergency incidents. Implementing a proactive program based on information and systematic assessment provides a manager with the tools to improve decision making and solid information on which to base staffing and funding decisions. Why perform a condition assessment? The compelling reason to perform a condition assessment of your collection system is to preserve the existing valuable infrastructure, minimize O&M, and avoid emergencies and unexpected costs. Performing a condition assessment has a cost for prioritizing work by focusing on critical assets and the maintenance and replacement needs for your collection system is an essential step towards better management. Condition assessment of your collection system is an investment in managing risk. In a condition assessment, data and information are gathered through observation, direct inspection, investigation, and monitoring. An analysis of the data and information helps determine the structural, operational, and performance status of capital infrastructure assets. A good written protocol consistently applied will help define the assessment. Structural assessment. If a sewer pipe is about to fail and you don't know about it, is that a problem? Structural problems can cause major headaches. Structural problems in wastewater collection systems can be caused by various factors such as cracks, faulty seals, and/or improper connections. Wastewater collection systems are also subject to aggressive chemical environments that can cause corrosion and deterioration of concrete and steel infrastructure over time, all of which can result in infiltration and inflow into the system during wet weather, which could result in overflows and operational problems at wastewater treatment facilities. Hydraulic assessment. Hydraulic capacity is a primary performance measure for a wastewater collection system. Capacity, both hydraulic and treatment, can be taken up by clean water entering the sewer collection system. Too much flow or constricted areas in sanitary sewer pipes can cause overflows or backups of wastewater into homes and businesses. Overflows and backups of untreated wastewater may spread disease and cause environmental damage. It may be obvious based on dry weather and wet weather flows that rainwater or groundwater inflow or infiltration, I&I, is a problem. Excess groundwater and rainwater can enter the collection system from cracks and holes in sewers and manhole covers. Illicit discharges of cooling water and illegal plumbing connections can also create flows which exceed the capacity of the sanitary sewer pipe. Preventive maintenance program. A preventive maintenance program is designed to help communities document knowledge as well as better understand their collection system. And by knowing the condition and critical areas of their collection system, a community can improve operations and implement preventive maintenance practices to help reduce or eliminate sanitary sewer overflows, or SSOs. A good preventive maintenance program is key to keeping a wastewater collection system in good repair. It helps preserve capital investment while preventing service interruptions and the excessive infiltration inflow and system failures that can result in sanitary sewer overflows. Unfortunately, in many cases, wastewater collection systems have fallen victim to the out of sight, out of mind syndrome. Far too often in the wastewater collection system only becomes a priority when a problem arises. However, with good records, regular analysis of these records, and use of this information, we can produce a cost-effective preventive maintenance program. Physical inspection. A physical inspection is vital to an O&M program. Without it, a maintenance program cannot be implemented in a systematic way, since system problems cannot be quantified. Elements of a physical inspection program include visual and equipment-based techniques that use established industry methods of system evaluation. Physical inspections should be performed on a regularly scheduled basis as a part of the preventive maintenance program. Inspection provides a detailed inventory of the system that includes size, material, condition, line sags, joint types, elevations, slopes, location of manholes and pump stations, location of building lateral connections, and other system attributes that are necessary for managing the entire O&M program. Inspection data provide location information that allows more efficient O&M planning and scheduling and emergency repair. During stoppages that involve overflows and/or backups, valuable time is lost if location information is not available, increasing the risk of regulatory violations, property and environmental damage, and threats to public health and safety. Inspection provides the data necessary for managers to make informed decisions on all maintenance, repair, and rehabilitation actions. This results in an O&M program that is effective and efficient. Purpose of conducting inspections. Identify what is in the system inventory. What size pipes do you have? What type material? In what condition are the pipes? Identify the location of the system's components. Are there any areas subject to stormwater runoff or any lines crossing creeks or streams? Determine the condition of the components. Are maintenance records available? And customer work orders? Are customer work orders available? Do these records indicate problem areas? Finally, prevent problems from developing. Benefits of physical inspection. Physical inspections are performed to accomplish the following goals: Identify defects in the system that can contribute to or cause backups, overflows, and bypasses. Identify chronic problem areas so maintenance can be planned and scheduled. Identify defects that, if not fixed, will result in a future failure. Determine the system needs for long-term replacement and rehabilitation. Assist in setting and justifying realistic user charges. In reference to those setting and justifying realistic user charges, most collection system improvement projects are funded by various federal and state agencies. Unfortunately, these funds tend to be overwhelmingly loan funds with little to no grant. This means that utilities must rely on the adequacy of their rate structure and the revenues it generates to fund these projects, which often results in a rate increase to the consumer. However, if the system has an adequate operation and maintenance plan, which includes preventive maintenance, then utilities will have an opportunity to communicate the current and potential future needs of the system to the consumer well in advance of any rate increases. Smoke testing. A smoke test is a sewer inspection in which a non-toxic smoke approved by the public health agency is blown into manholes. The smoke makes its way through all of the connected pipes in the sanitary sewer, helping to locate pipe leaks, broken manholes, cracks, uncapped lines, and more. Smoke testing is a relatively simple process which consists of blowing smoke mixed with larger volumes of air into the sanitary sewer line. Usually induced through the manhole, the smoke travels the path of least resistance and quickly shows up at sites that allow surface water inflow. Smoke will identify broken manholes, illegal connections, uncapped lines, and will even show cracked mains and laterals, providing there is a passageway for the smoke to travel to the surface. CCTV, closed circuit television. CCTV evaluation can determine the specific location and cause of I&I in many cases. However, flow data gathered by flow meters has been used to guide sewer system capacity and management for decades. Flow data can be used as a tool in condition assessment, either to identify areas for further CCTV inspection or to quantify the severity of I&I identified during CCTV work. Any components of the system located along streams are particularly vulnerable to the effects of rainstorms. Each sewer crossing of a stream should be inspected to be sure the sewer is not in danger of being broken. Also, the manholes on each side of the stream should be checked to see that no excess flow is taking place, which would indicate a leaking sewer under the stream. Since these sewers are often in remote locations, they are susceptible to vandalism and can overflow for long periods of time without detection. CCTV inspection is generally used in one of two scenarios. The first scenario is where there is a sewer line that needs to be inspected for potential repairs. The second scenario is when there is a sewer line that has already been repaired and the inspection is being done to ensure that the repairs were effective. CCTV inspection allows for reaching deep inside sewer pipes far underground and seeing them in detail to spot any damage. Without the use of pipe inspection cameras, it is frequently impossible to assess how extensive sewage pipe damage is and where it is situated. Flow monitoring. Flow monitoring equipment is used to identify areas of the collection system that have rainwater inflow or groundwater infiltration problems. Flow monitoring can also detect areas where surcharging may occur because the volume of wastewater to be carried is greater than the capacity of the sanitary sewers to convey that amount of flow. Surcharging problems can result in sanitary sewer overflows when wastewater rises to the top of the manhole and flows onto the street or to the ground. Flow meters are placed at varying locations throughout the collection system. These meters measure the amount and rate of wastewater flow in the sanitary sewer lines. The monitors are left in place for a specified period of time. Data is collected and compared to rainfall amounts over the same period. Measurements taken before and after a rainfall event indicate how much I&I contribute to the total flow of wastewater in the collection system. Flow monitoring is an essential procedure to collect data for evaluating and characterizing wet weather and dry weather flow conditions in sanitary sewer collection systems. While many do not have flow monitoring equipment within their collection system, there is certainly flow measuring capabilities at the treatment facility with which dry weather versus wet weather flows can and should be analyzed. Manhole inspections. Visual and televised inspections verify that manholes and cleanouts are on proper grade and are accessible to maintain sewer lines. Sewer line maps, which indicate distances to fixed objects such as hydrants, telephone poles, streetlights, etc., from installed manholes can be used to locate manholes or cleanouts that are paved over or concealed. Manhole inspections are a relatively quick and inexpensive way to detect holes and leaks that allow rainwater or groundwater to enter the collection system. Manhole inspections should include the exact location of the manhole, the need for any grade adjustments, leaks or holes in the cover or frame, evidence of rainwater ponding on the manhole cover, the condition of sewer pipes and lateral connections. Lift station inspections. A lift station is an installation of pumps that raise water from areas too low to drain gravity into sanitary sewers. A typical weekly lift station inspection should include observations that confirm alarm systems are operating properly. That alarm system could be an audible alarm, or in many cases, a visual flashing alarm. Wet well levels are properly set. All indicator lights and voltage readings are within acceptable limits. These are all tools that at the disposal of the operator that should be utilized in performing routine maintenance, operation and maintenance on a sewage lift station? Are the pumps running without excessive heat or vibration? Do they have the required amount of lubrication? Do the belts show any sign of excessive wear? These are all things that should be documented and maintained and reviewed regularly to prevent and to ensure the continued operation of the lift station. Sewer laterals. The sewer lateral is an essential component of a wastewater collection system. This plumbing system component ensures that waste from your home is safely discharged to the sewer main. A utility should not neglect problems with sewer laterals, as there can be significant problems on laterals that negatively impact the operation and maintenance of the collection system. These problems can be identified through efforts such as smoke testing, CCTVing, and customer work orders. No discussion on sewer collection systems can be complete without also considering the hazards of the occupation. There have been many things that we have discussed during this presentation that would require the operator to come in close proximity with many dangerous chemicals and devices. Sanitary sewers may contain harmful gases such as hydrogen sulfide or methane, or low concentrations of oxygen. Hydrogen sulfide gas is produced by anaerobic bacteria in slow-moving wastewater. This gas is a major source of odors in collection systems and smells like rotten eggs. Heavier than air, hydrogen sulfide gas is often in the lower portion of manholes. If the concentration of hydrogen sulfide or methane gas is high enough, unconsciousness will come suddenly to workers exposed to this gas. Each collection system utility should have a confined space safety program that includes a written plan, entry procedures, and the appropriate 3 gas monitoring meters for hydrogen sulfide, methane, and oxygen. When entering a manhole, use the proper safety harness, calibrated gas detection devices, and ventilation equipment. For more information, see the Occupational Safety and Health Administration confined space regulations at the website listed on the screen. In conclusion, while we recognize that a certain approach may not be directly applicable to every situation, we hope it might provide a new idea, a useful template, or perhaps a potential contact as you work to prevent overflows and improve your collection system. This is the end of my presentation, and I thank you.
Awesome. Thank you, KT. So we do have a couple of questions for you.
Okay.
This one came in at the beginning of the presentation. Pascal wants to know how smoke testing works?
How does smoke testing work?
Yes.
Okay. So as stated during the presentation, smoke testing is utilized in order to find places, cracks in the lines, places where stormwater, rainwater, infiltration, groundwater is entering into the system. So there are a number of ways of doing this. Uh, One of the most common is with a non-hazardous oil and a blower. So imagine, if you will, placing this blower, which is a huge fan, on top of a manhole. And we apply this oil to the blower, and the heat from the blower creates a smoke. The blower blows that smoke down into the sewer main, and 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 then as the slide indicated, the smoke takes the path of least resistance. So what happens is wherever there's a break in the line, the smoke will surface. Now, you'll also have smoke surface from clean outs in the customers' yards. You'll have smoke to surface from the stacks on top of the house. But smoke testing may also reveal problems with individual plumbing. For example, if a customer comes out and says, there's smoke inside of my home, well, that's an indication that there's a break in the sewer line in close proximity to the home. But in essence, smoke testing works by creating a smoke from the blower with this specific oil and blowing that smoke throughout the collection system.
Wonderful. Thank you for that answer. The next question is, what specific time slot do we need to change over the standby pumps and lift stations?
Could you repeat that question?
What specific time slot do we need to change over the standby pumps and lift stations?
I'm assuming that the question is that he's got pumps in a lift station. Well, some are of regular use and others are standby. And perhaps the standby pumps don't get utilized very often, assuming that the standard pumps are operational. If that is the case, so in many cases, you've got pumps in a station that alternate. Most lift stations are duplex stations, or sometimes triplex, meaning they've got 2 to 3 pumps and possibly even more. And those pumps will alternate on a regular basis. However, if you've got pumps designated as standby pumps, I don't know that there's a particular rule of thumb as to how often you should switch those over. But from an operator standpoint, I would say as often as I needed to be reasonably sure that when those pumps were needed, that they would work, whether that be once a week or once every 2 weeks or once a month. But certainly I wouldn't recommend any longer than once a month, just to ensure that the standby pumps are in fact operable.
Perfect, thank you. And then I have a couple more questions about the smoke test. Someone asked, can the smoke enter a residence in a shower or bathtub area?
Indeed, the smoke can and often will enter a residence. If that happens, that's an indication that there's an issue with that customer's plumbing, because the smoke will only enter through a break in the line. So if you're performing a smoke test in a neighborhood and the customer comes out and says, hey, I've got smoke in my bathroom, well, that's also an indication that there's a separation or a crack in that customer's sewer line from the lateral, from the main as it goes into the house, there's a crack or separation of some sort in that line. And it's an excellent way of identifying problems, not only on the main lines and the collection systems, but also on the laterals, including inside the home. Of course, inside of the home, you're not as susceptible to inflow and infiltration, but that customer could be susceptible to the sewer gases, the odors that originate from the sewer. If the smoke it finds a way into the home, then those sewer gases can as well.
Perfect. And the next question is, can you please provide a ballpark number for the cost of a smoke test? For example, price per foot or manhole or per day?
Well, I think this answer will vary considerably depending on where you are. For example, in Mississippi, which is where I am, the cost is it's a service provided by our local rural water association. So Mississippi Rural Water performs most of the smoke testing here in Mississippi, and it's a nominal fee, almost free. Maybe less than $200, which covers the cost of the oil. So the service is a free service, but there may be a small charge for the cost of the oil. So in other places, I'm not exactly sure how it works, but typically it's a service that may be offered by an engineering firm or maybe even plumbing companies. I can imagine this service could get expensive. Fortunately, in Mississippi, we don't have that to be concerned because rural water provides the service at no cost. But I would encourage whomever asked the question, to contact their local rural water association and get some information as to if that's a service they provide. If not, then they could certainly point them in the right direction. But to answer the question, it's there's not an average cost. First, it's all over the ballpark if you had to pay for it. And unfortunately, in our situation, we just don't have to.
All right. And the next question is also on the smoke test. Could the smoke not also enter via a dry P trap in a shower or sink, perhaps a trap that has dried out due to infrequent use of that fixture?
Yes, it could if it's a vacant home or for whatever reason that particular restroom or facility has not been utilized in some amount of time and the trap is dry, then smoke would certainly enter. That's not common, but it's certainly a possibility.
All right. And I think this is the last question. Why would one not want a 4-gas meter to include CO?
Say that one more time.
Why would one not want a 4-gas meter to include CO?
As opposed to a 3-gas meter?
I'm assuming that's what they meant by that question.
Okay. To be perfectly honest, I would think that a 4-gas meter would be perhaps more uh, perhaps even more so appropriate than a 3-gas. So to answer the question, I believe that a 4-gas meter would be better in instances of entering a manhole.
All right, I just got another question. Is corrosion a concern for ductile iron pipe?
Well, the answer is yes, but also there's not. Well, of course, I'm answering this question based on my experience. There's not a lot of ductile iron sewer pipe, but corrosion certainly would be an issue. Of course, now that's not to say that there's not some ductile iron sewer lines in certain applications, crossing streams, but in most instances, those are used as casings. So the answer is yes, but I don't know how prevalent ductile iron sewer lines are. They're not prevalent in my area.
All right, and then I have just one comment. Steve says that he has reduced his sewer backups by using root killer down the sewer lines instead of root augers when the condition is occurring.
Root killer instead of, okay. Is that something, is that something that he could share, like a brand name or something that we could all see?
Let me respond to him and see if he's still here with us. 1 second. All right, he says that he uses root X.
Root X.
And
Okay.
I did just get another question.
All right.
With odor issues in lift stations, how can we prevent that?
Odor issues in lift stations?
Yes.
Well, so I guess the question is the origin of the odor. Is it a lift court? So it could be a lift station that doesn't run very often, and perhaps the or perhaps the wastewater inside of the lift station is turning septic, which I doubt that's the case. But if it stayed in there, a long time, then that could be. You could increase the frequency with which the lift station runs, uh, by adjusting the floats. That may help. To be honest, that's really about the only thing that I can think of. Of course, most lift stations are vented. They have a vent to the atmosphere to release much of this gas and methane and hydrogen sulfide. So the area right around the lift station from time to time could have objectionable odor. But if it's a result of the station not running very often, I would try adjusting the floats to see if I could increase the frequency with which it cycles.
All right, and I have just one more comment. Alyssa says the only thing about root killer, make sure that you check with your wastewater treatment plant operator. We've had issues here with people killing the plant biologicals by using large amounts of root killer.
That is exactly right. I was thinking that at the time. That's a great comment.
All right, thank you so much, KT, for staying on and answering those questions. And thank you for sharing your expertise with us today. Following this webinar, each of you will receive a follow-up email with the slides from today, as well as a link to this recording. We ask that you complete the webinar evaluation following this webinar so you can let us know your thoughts on today's session. This helps us plan for future webinars that are on topics that are important to you. Thank you again. We hope to see you all at future EFC and events.
Thank you.
Thank you, KT. Bye, everyone.